Okay, in this video, we're going to be going over antiderivatives or integrals. So what is an integral? Well, an integral is, let's do an example here. Say you have this right here. Okay, well, this is a derivative. And what we're going to do is we're going to take the antiderivative or the integral, and we will get back the function that gave us or produced this derivative. Now, here are some examples for trig functions. For example, if we have in our problem cosine, and we'll see these later, we'll know that the integral of cosine is the sine. And it's interesting because you see it's just undoing that derivative. So if we wanted to take the derivative of sine, we would get cosine. Cosine, we would get negative sine, so on and so on. But we'll see that when we go and we try to find our integrals, it's just the reverse of this. So it's an undoing. That is what an integral is. It is an undoing. Okay, so let's get to it. Now we're going to see in this video 3 types of integrals, and they're going to follow these patterns. So we'll have, and you just want to decide, you want to start looking and trying to put together what integral do I have here. You want to make it to where it'll get in this one of these orders, and then you will know how to integrate it best. And I know it looks kind of strange at first because you're like u to the n du, and what is all that? So we're going to see what that looks like. This is called a power rule integral. So let's see what a power rule integral would look like. So we have 5x to the third. I'm just rewriting the one from above, so that way we can see our powers clearly. See your power clearly, right? Okay. And so now if you look here, we have u to the n du. Well, our n's are our powers. And so what we're going to do is we're going to integrate these like this, like individually. And that is what this S-looking thing, can't forget our dx, this S-looking thing right here, that just means the integral. Okay, so what we're going to do is our 5 here is just a multiplier, our 4 is a multiplier, and so just like we wouldn't take a derivative of that, we're not going to do anything with it to integrate it, because if it doesn't affect the derivative, it's not going to affect the integral. All right, so the integral of 5x cubed is going to be 5x to the 4th. So we're adding 1 to the power and dividing by that new power. Minus 4x, well, if you add 1, that's 2 over 2. So this is going to be 3 over 2 divided by that new power. And you'll see that we have this pattern right here. U to the n plus 1, which is this power, 1/2, plus 1, divided by n plus 1, plus a constant of integration. Now, what in the world is a constant of integration? Well, a constant of integration, say I have the derivative, or let's say I have a function that is 2x squared plus 5x plus 6. Okay, so say I have this. Well, if I took the derivative of this, I would get 4x plus 5. Well, this 6 right here, he's there technically, but he's plus 0. So what this is doing is this c is taking into account the fact that we don't know if we had a constant of integration. And all of the ones that we're going to do in this video are going to be like that. And an integral that has this constant of integration is called an indefinite integral. And we'll see in another video how to do definite integrals. And that is just an integral that has limits on it. Okay, so for the purposes of this video though, you want to make sure that if your integral just looks like this, that you always have this plus c. Okay, so let's simplify this a little bit more. So we have 5/4 x to the 4th minus, well, we know when we divide by a fraction, that's the same as multiplying by the reciprocal, right? I'll just show it. Which further simplifies to there we go. And that is how you would work an indefinite integral. Now, something that's really good for when you're practicing these, and I'm not going to do it for all of these because we should know now how to take derivatives, but it's still really good practice, is that after you do your integral, go back and see and take the derivative of this. And you'll see how you got this to begin with, because this is your derivative. So I'm going to do it with just this one. So we're going to take the 5/4 out, that's just a multiplier. If I were to take the derivative of x to the 4th, that's going to be 4x to the 3rd minus, and we have our 8/3 as a multiplier, x to the 3/2, we're going to bring that 3/2 down, and then it's going to be x to the 1/2. Okay, and so then these will cancel. That's 5x cubed minus, that'll cancel. 8 divided by 2 is 4. X to the 1/2, which equals 5x cubed minus 4, and that's x to the 1/2. And you'll see that this indeed is the very same thing as that. And it really helps to solidify what you're learning, because you realize, yes, this is indeed the derivative, and this is the original function, the integral. Another thing that you'll see that this is called is the integrand, and this is the integral, the finished integral. All right, so let's do another example. Okay, so here we have some trig. Well, that's why, and I did this, I do this on a test. I actually just took a test today, and when I went in, the first thing I did was I dumped from my brain these main derivatives and integrals, because it allows when you're working to not really have to think about it, while you're doing it. So I find that that's helpful to just write it all down at first, and then to go back and see what we've got. So like right here, if I'm looking over here, well, this that I'm looking at is a derivative. So I know that I need to look over here for a derivative. Well, I don't have cosecant as a perfect derivative. I don't have cotangent as a perfect derivative. And so that means I'm not going to have a perfect integral, because I have to have the perfect derivative, the perfect du, to get a perfect integral. And we're going to talk more about that du in a little bit. So what I'm going to do right here is I'm going to multiply. I'm going to go ahead and distribute this to cosecant. So now I have, 10 cosecant squared x minus 8 cosecant x cotangent x, and don't forget the dx, that means with respect to x. Now if we look over here, is cosecant squared a perfect derivative? It is, it just needs a minus sign. So what we would do is our answer would be negative cotangent. So we're going to have a negative 10 cotangent x. Okay, now we have cosecant cotangent. Well, we have the same thing here. So the perfect integral of this derivative would be cosecant x. However, we don't have the negative here, so we need to go ahead and account for that negative. And so we would say negative 8 cosecant x. Well, that is then going to give us a positive. And don't forget your constant of integration. Okay, so if we look here at this integrand, how are we going to integrate this? Now, one thing that I have found is you really want to try to get creative so you can make this as simple as possible for yourself. So if you have just a plain old x or x to a power in the bottom, and your power is smaller on the bottom than it is on the top, or the same as, then why don't we see if we can divide each of these by that, because this is equivalent to this. Oh, I forgot the dx. Okay, so then we'll simplify that. Okay, so when we're looking at these right here, we see that when we integrate this, we are just integrating the power. We're integrating the n, and we're going to do that by modifying n plus 1 divided by the n plus 1. But what is this? Right? So if you had, let's do it like this. You have to pick a u. This is u substitution. So since we have x and we don't have a perfect derivative right here for this x squared, what would it be? So our u would be x squared. So our derivative of that would be 2x. Okay? Well, that isn't going to be able, like, we can't just put a 2 and an x in. We can put in a constant, but we can't ever multiply by anything other than a constant that is equivalent to 1. So what I'm going to do is I'm going to rewrite this so we can see better that this is actually, and now it's easier to see what we need to do with this, and we see that it is n plus 1. So sometimes you just have to rewrite it and then work your way from there. Okay, so now what we're going to do is we're going to start to integrate. When you start to integrate, here we're still doing piece by piece integration using the power rule integral. And so you don't have to do that once you start to integrate. So it's going to be 4x, add 1 to the power, divide by the power. The integration of 7 would be 7x, because what? The derivative of 7x would be 7. And this is an undoing of the derivative. And then you have 5x. We'll add 1 to the power. It's just going to be minus 1. Divide by that new power. All right, so now let's go ahead and clean this up a bit. And you could go ahead and get a common denominator. I should probably keep that plus c, don't forget him. So we can have a common denominator of 3x. So if we did that, we would multiply this by, well, we need an x, so this will be 4x to the 4th minus, and the next one we need a 3, so that'll be 21x. And then, oh, I lied. We need a 3 and an x because he has nobody. He has nobody in the bottom. Oh. And then for the next, we need a 3. And this is going to be all over 3x plus c. And like I said, make sure that you're checking these and taking the derivative of them so you can understand where all this stuff goes and how you get back to that. Okay, so here we go. We have the integral of 3 cosine x minus 2 sine x dx. And if you have instructions for this, and all of the ones for this video, the instructions will just say integrate. Right, because that's all we're doing. Okay, so when I look here, I'm saying what gives me the derivative of cosine x? So I'm going to look over here at my cheater box that I wrote down. I did a brain dump. So I see that I get the derivative cosine x from sine x. So the perfect integral of this is just sine x. Now what gives me the derivative sine x? So I look and I see, well, cosine x gives me negative sine x, so I need to account for this negative. How do I account for the negative? Because I can't just change the value. Well, I multiply by a negative over a negative, right? That's the same as multiplying by 1. Well, my negative needs to go right here. All right, so I haven't changed anything value-wise. So then I'm going to integrate piece by piece. And we said that the integral of, when you get the derivative cosine, you get the integral sine x. And then here we're going to get a plus because we have those two negatives. And then don't forget your constant of integration. Okay, so now we're going to look at this. Now, up until now, we've done piece by piece integration, but you can't really do that here. In order to do that here, we're going to be actually picking a u and then finding a du, adjusting what we have in the problem by multiplying by negatives or constants only, and then we're going to integrate. Let's see what that looks like. Okay, how do I pick my u? Well, my u is going to be the thing inside of stuff, the most inside of things. So if you see things that are in parentheses or that are inside of a square root, that is your u. So u equals x to the third minus 8. What is the derivative of u? Well, that's going to be 3x squared. Don't forget your dx. Okay, so then I look here in my problem. Well, I don't have 3x squared. I have an x squared, dx. So what I'm going to do is I'm going to multiply by 3 over 3. That's equivalent to multiplying by 1, so I haven't changed the value of the integrand at all. And what this ends up looking like is multiplying by 3 and dividing by a third. And now we have our perfect du. So what are we integrating? We are now integrating u du. Well, how do you integrate u du? Well, it's the u to a power du. Well, what is our power here? Our power is x to the third minus 8 to the 1/2, because that's what the square root is equivalent to. Now we have to make sure that we bring down the multiplier of the 1/3 and include that in our integral. So this is what we're integrating. Well, we're still integrating this whole thing, but this is the part that you're actually integrating. So what you're then going to do is say, but you want to have this integral here the whole time, but I just want to show you what you're actually integrating. So if you bring this down, what you're going to get then is, we don't need to do that, 1/3 times x to the third minus 8. And then if you have 1/2, right, that's what that equals. Well, plus 1 is going to be 3 over 2, right? So you have 3 over 2, and then you also have to divide by that power, which we see right here. You have n plus 1, which was 1/2, plus 1 equals 3 over 2, and then divide by that new power of 3 over 2, plus your constant of integration. And then you want to make sure that you clean it up here. So since we're dividing by a fraction, that's the same as multiplying by the reciprocal. And then we're going to have 2/9 times x to the third minus 8 all to the 3/2 power plus c, and that is our integral. Okay, so here we have that we are taking the integral of secant squared 4x dx. Well, if we look here, we see that secant squared is a perfect derivative of what? Tan x. So we're not going to integrate this with the power because then that would be integrating secant, and secant isn't a perfect, integral. So, but secant squared is. So what we're then going to do is we're going to set our u equal to our angle of 4x. Our du will be 4 dx. And so the only thing that we need now is this 4. So let's go ahead and multiply by 4 over 4, which is the same as multiplying by 4 and multiplying by 1/4. And then we have 4 dx. Now, as soon as you have your perfect du, you can integrate. So then we'll have 1/4 tan 4x plus a constant of integration. Okay, so for this one here, we notice that we have the parentheses. We have something that's wrapped up to a power. So we know that our u is going to be the thing that is in the parentheses. So let's set our u equal to the thing in the parentheses, which is x squared minus 3x plus 2. So our du is going to be 2x minus 3 dx, which we see we already have the perfect derivative right there. Now, you can get tripped up by this because you can say, okay, well, this is du over u, so maybe this is a logarithm, but it's not a logarithm because we have this power. So this could actually be rewritten as 2x minus 3 times x squared minus 3x plus 2 to the negative third power dx. So the thing that we are going to be integrating, because now we have what? duu, which, if we look at our little cheater box right here, we see is a power rule integral. So we're going to be integrating the x squared minus 3x plus 2 to the negative third. So we are integrating that power, which is negative 3. So add 1 to the power, that's negative 2. Divide by that power, add a constant of integration, then we're going to make it look pretty. Negative 1 over 2 times x squared minus 3x plus 2 to the 2 plus c. And that is our integral. Okay, so here we have the integral of 5 cosecant squared 2 theta over cotangent to the 5th 2 theta. Now again, we have a power in our denominator, so this can be rewritten as the integral of 5 cosecant squared 2 theta times cotangent to the negative 5th 2 theta d theta. Okay, and so we're going to look over here. Well, cosecant squared, is that a derivative? Well, we have that negative cosecant squared x, or in this case 2 theta, whatever the angle is a perfect derivative of the integral cotangent x. Well, what about, we have cotangent right here. So, but that's not what we're going to do. So if we have cotangent though, okay, so I'm not going to edit out that confusion because I just realized since I wrote this down before that I could set my u equal to cotangent and integrate the cotangent, and then I would have u du, and then that would be my power. So let's do that. And see, you'll do that. Sometimes you'll start out on something and you'll think, okay, well, this is the road that I'm going to go down, and then you realize maybe a different road is better, and that's fine. So let's go ahead and let's set our u equal to cotangent of 2 theta our du is going to be cosecant squared 2 theta. Don't forget to chain rule derivative the angle, which will give us a 2 d theta. And so we need a 2, but we have a 5. Well, that's fine because our 5 is just, he's just a multiplier, so we can bring him out front and stick him on the porch. And then we have a 1 over 2 times 2 cosecant squared 2 theta d theta. We'll just put it all together so it's easy to see. And then I'm going to need some more room here, so I'm going to bring this down here. D theta. And then I have cotangent -5 2 theta d theta. Okay, so now I have du, which we know is a power rule integral, and I'm going to be integrating now the -5th power on the cotangent. So we have 5 over 2. Oh, and I also needed this to be a negative, remember? Because up here, this is a negative to make it a perfect. So -5 over 2. And then it's going to be cotangent. Add 1 to -5, we get -4. Divide by -4. Don't forget our angle. Plus c. And then we will integrate. This will give us 5 over 8. Let's do it like this. 5 over 8 cotangent to the 4th, because it's the same when you have -4 as having to the 4th in the denominator, plus c. And that is our integral. Okay, so for this one here, let's go ahead and let's rewrite this so we can see that we are to a power. So I have sine to the -5th 3x dx. I'm going to set my u equal to sine of 3x. My du will then be cosine of 3x times 3 with respect to x. And so all I need for my perfect du is that 3. So we'll multiply. This will be a 1/3 and a 3. So that means I'm going to bring that 1/3 along to multiply 1/3. And now we're going to integrate the power. Okay, so this is going to give us 1, actually be negative, over 12 sine to the 4th 3x plus c. Now, say you decided for this one to make cosine. You say, well, I could have made cosine my u. Well, not in this case because you have this -5 power, and that's the thing that we want to integrate. But say you just had cosine to 3x, sine to the 3x, you could have done either one, and then it would have required the negative sign, and you would have been able to do it that way. But if you have a power, you want to integrate the function that is inside of that power, or inside of the parentheses, or inside of the square root. Okay, so for this one here, we have 5e to the x divided by 4 plus 3e to the x. Well, if we look here, if you have just one e to the u, then the u will be the power, and you're just going to integrate that plus c. And the derivative of e to the u is always just e to the u. He never changes. He's always the same no matter what you do to him. So we have 2 e to the u's here, so we can't go by just that. So we're going to do what we normally would do and set the denominator equal to u and see what happens. Okay, so right now we have a 5 e to the x, so let's bring him outside. And let's also multiply by a 3 over 3. So that way we have what we actually need for our perfect du. Now, you'll notice that we don't have this bottom raised to a power. He is just, e to the x. Let me clean that up a little bit. So now what we have is a du over u, which if we look up here at our little cheater box, we see is an ln. This is a logarithm. So our logarithm is going to be 1/3 times 5, so that's 5/3 ln the absolute value of 4 plus 3e to the x plus a constant of integration. Okay, so for this one, we see that we're going to set our u equal to what is inside of our square root. Our du is going to be negative 8x dx. Well, we have a 7, so let's bring him out front, and we're going to multiply by an 8, a negative 8 over a negative 8, so we're not changing anything. Okay, and so we can also then rewrite this so we can see what power we are looking at up front, or up top. Negative 1/2. And this is going to be negative 7 over 8. All right, and so now we're going to integrate this power, and we do that by bringing our multiplier down. And then we have 9 minus 4x squared, add 1 to the power. That's going to make this 1/2. Divide by that new power, plus a constant of integration. And then we clean it up. Times that, so that's going to be negative 14 over 8, and then that'll be negative 7 over 4. I'm just going to get rid of those. Times, and then we can put it back the way that the question gave it to us underneath the square root, plus c. And that is our integral. Okay, for this one here, we're going to set the bottom equal to u. We'll take the derivative of that, which is 2x minus 8 dx. But if we look at our problem here, we see that we have x minus 4, and we cannot multiply by anything other than a constant, which is equal to 1. So in order to do that, we can just factor out a 2. And then you see that we have in our problem the 2x minus 4 dx, or we have the x minus 4. All we need now is to multiply by that 2, and then we can look at what we have. So then we will have, well, if we look up here, we'll see that we have du over u. So anytime, if you've noticed, anytime that you have something that's in the denominator, just like a polynomial that's not raised to a power, and you're not going to be dividing out the x's and things like that, you're working with a logarithm. So that's what we have here. This is going to be 1/2 the ln of the absolute value of x squared minus 8x plus 25 plus a constant of integration. Okay, so if you have only one e to a power, that's when you're going to be integrating e to the u du. So if you have only one e, the u must be the power. So we have u equals minus 2x. The derivative of minus 2x is just minus 2 dx. Again, we bring our 5 out. We'll multiply by a minus 2 over minus 2. And then we have our perfect du and a u. So we have e to the u du. And what that's going to give us is we have our multiplier that we have to bring along, and then our e to the u. He doesn't change no matter how much you try. He doesn't change. Okay, and I want to do this last one. So this one right here, you see that we have more than an x in our denominator. We have an x plus 1. So we don't yet have the tools. I don't know if they appear at some other time, but we don't yet have the tools to integrate this. But we can integrate it if we handle this using long division. So let's do this real quick. Oops, I lied. Not like that. 4x to the 4th minus 0x cubed. Well, we can say plus because that's just 0. Minus 7x squared plus 0x plus 5, all divided by x plus 1. Okay, so x goes into 4x to the 4th, 4x cubed times 4x cubed times x, so we're coming back down, equals 4x to the 4th. And then you have to multiply this 4x cubed plus the 1, and that's going to give you a 4x cubed, positive. You have to wrap this up and you're subtracting. So when you're subtracting, that first is going to go away. And if you've done this correctly, that will happen every single time. Then you get a minus 4x cubed. Bring down your negative 7x squared. Okay, so now we're going to say x goes into negative 4x cubed. Well, negative 4x squared times, right? And then we're going to multiply negative 4x squared times x. So then you come back down here. That's going to give us negative 4x cubed. And then you multiply that by a 1. You get negative 4x squared. Wrap that up, minus sign. The first goes away. Then you get negative 7x squared minus a negative. That's a plus. So we're going to end up with a negative 3x squared. Bring down your plus 0x. Negative 3x squared. X goes into that. Negative 3x times, and then negative 3x times x is negative 3x squared. Negative 3x plus 1 is negative 3x. Wrap that up, minus sign. First one goes away. Then you get a positive 3x. Bring down your 5. 3x, x goes into that 3 times. 3 times x is 3x. 3 times 1 is 3. Wrap that up. Add a minus sign. First one goes away. 5 minus positive 3 is a 2. And you have to write this as plus 2 over x plus 1. Hopefully you remember your long division. If you don't, there is a real quick pick-me-up. Now that's not our answer, so I probably shouldn't circle it. But that's that. So this now is what we're going to integrate. So this is going to be the same as us integrating 4x cubed minus 4x squared minus 3x plus 3 plus 2 over x plus 1. And then what we're going to do is we're just going to integrate by parts. So this is going to be a power rule. So we're going to have 4x to the 4th divided by the power. 4x to the 3rd, because we're just adding 1 to the power, divide by the new power. Minus 3x squared, divide by the new power, plus 3x. Now this one right here, if we look, our u is going to be x plus 1. Our du is going to be 1. So we're just going to bring that 2 out. He is now a multiplier for this, and we're going to have 1 over x plus 1. This is du over u. That's a logarithm. So we are going to have plus 2 ln absolute value of x plus 1 plus c. So let's put this all together. X to the 4th minus 4x cubed divided by 3 minus 3x squared divided by 2 plus 3x plus 2 ln of x plus 1 absolute value plus your constant of integration. So it seems nasty at first when you have to do the long division, but it's quite easy to integrate once you do that. All right, so keep practicing.